Hello guys, welcome back to my YouTube channel. Today I am going to solve day 25 problem of this month on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Okay, so in this problem we have given one nums array. So this is one given one nums array, and we have to find whether we can traverse each element in my nums array, and we can only traverse if the greatest common divisor of any two numbers is greater than 1. Okay, so let's understand this with one example here. So let's say nums array given to me is like this. Nums is equal to 2, 2, 4 or 3 or 6. Take one more number, let's say 6. Okay, so this is one nums array. Okay, so here from 2 to 4 can I go? So what are the factors of 2? Okay, what are the factors of 2? So factors of 2 are nothing but 1 and 2. Okay, these are the factors of 2. And what are the factors of 4? Okay, what are the factors of 4? Factors of 4 are nothing but 1, 2 and one more 2. Okay, what are the factors of 3? Factors of 3 are 1, 3. Okay, and what are the factors of 6? So factors of 6 are 1, 2 and 3. Okay, these are the factors. Okay, so can I move from number 2 to 4? Can I move from number 2 to 4? Yes, I can move from 2 to 4 because they both have the one same factor. And here one more thing. If and only if GCD of any two numbers is greater than 1. So let's ignore this one. Let's ignore this one. Okay, we don't need to take this in consideration. So can I move from 2 to 4? Yes, because both the numbers have one common GCD. Okay, so yes, I can move from 2 to 4. Okay, so I have reached this 4. From 4 to 3 can I move? No, because there is no common factor among them. Okay, there is no common factor among them, among 4 and 3, so I cannot move. So this is not the case, okay, right now. But can I move from this 4 to 6? Yes, I can move from 4 to 6 because both 4 and 6 have one common factor, right? They have at least one common factor, so I can move from 4 to 6. Okay, so I have reached to this 6. From 6 can I move to this 3? Yes, because both 6 and 3 have one common factor, 3 and 3, right? So from 6 I can go to 3. Okay, so in this way I am traversing all the elements in my nums array, right? So for this case I have to return the output as 2. So I hope that you guys are clear what we are doing here. So here now let's read the example 1. Nums given to me is 2, 3, 6, and in this example there are total 3 possible pairs of indices. One is 0, 1, 0, 2 and 1, 2. These are index, right? So to go from index 0 to 1, from 0 to this 1, okay, this one we can't go directly because there is no common factor. So we can use the sequence of traversal, like first I go to this 2, then I go to 6, then I go to 3. Okay, that is I go from index 0 to 2 and then from 2 to index 1. So this is what is mentioned here, right? Where we move from index 0 to index 2 because GCD of num 0 and num 2 is, that is 2 and 6 is 2, which is greater than 1. And then move from index 2 to 1 because GCD of nums 2 and num 1, that is GCD of 6, 3 is 3, which is greater than 1. Okay, to go from index 0 to 2 we can just go directly because GCD of numbers is 2 greater than greatest common divisor, right? So likewise to go from index 1 to index 2 we can just go directly because GCD of numbers num 1, 2 is equal to 3. Okay, so we have to return the true if it is possible to traverse between all such pair of indices. Okay, so we can traverse between all such pair of indices, like from 2 to 4 I can traverse, from 2 to 6 I can traverse, from 2 to 3 I can also traverse, but this is the route. This is going to be my route, this way, or this is also one possible way to traverse from 2 to 3. So I have to traverse between any two indices should be true. Like from 2 to 3 I should be able to move, from 2 to 4 I should be able to move, from 2 to 6 I should be able to move. Okay, so in all the indices we have, if return true, if it is possible to traverse between all such pair of indices. So these are the indices different indices 0, 1, 0, 2, 1, 2. Okay, So we have to return true if it is possible to traverse between all such pair of indices. So I hope that you guys are clear with this. So now to solve this problem, I'm going to use union find data structure, and let me tell you how I'm going to implement this. Okay, so this is nums array, output is going to be true only. Okay, so this is my array, right? So first I'm going to find what is the maximum number in my nums array. So maximum number is 6, right? 6 is the maximum number. 6 is the maximum number. Okay, 6 is the maximum number. So definitely the maximum factors that I am going to get for any number is till 6 only, right? Till 6 only, because here first you guys know what are the prime numbers and what are the composite numbers. So prime numbers are nothing but this. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, and so on. Okay, because these numbers can be divisible by 1 or by itself. Okay, but 4 is not the prime number, it is a composite number because it is divisible by 1, it is divisible by itself, and it is divisible by one more number too. Okay, so that is why it is a composite number. So these are the prime numbers. Okay, so now I have find the one maximum number. So here I'm going to write all the numbers, like what are the different factors that I can get for a particular number. Like for 6 I can do it like this. 1 into 6 is 6, right? 2 into 3 is nothing but 6. 3 into 2 is nothing but 6. Is there any other way? Yeah, 6 into 1 is also 1. So what are the different factors that I get for a 6 maximum number? 1, 2, 3 and 6. These are the different set, right? Different factors that I get for a particular number, right? So here let me write all the numbers here. 1 is the case, 2 is the case, 3 is the case, 4 could be a number, 5 could be a number, 6 could be a number. Okay, so here let's consider like let's consider maximum is 6. So let's consider all the numbers till my 6, and these all numbers are divisible by itself, right? So let's say this is a one parent group. Okay, this is one parent group, and all these numbers are divisible by themselves. So let's place them in one parent only. So let's say all these numbers, these are the numbers, all these are the numbers. Okay, parent of number. So parent of 1 is 1, parent of 2 is 2. So let's say all these numbers are divisible by themselves. So let's create the group for them, and all these numbers I placed them in their own group. Okay, 5 is divisible by 5, 6 is divisible by 6. Okay, so I have considered like this. So these are my numbers, these are my parent. Okay, so now let's do one thing here. First here let me create one space here. Okay, so now what are the factors of 2? So let's iterate from I is equal to 2 to till my max divided by 2, because the maximum factors, that this is the maximum number na. So for this 6 is the max number, right? 6 is the max number, 6 is the max number. And what are the factors of this 6, right? 2, 3 into 1. Okay, 1 we don't need to consider. So till 2 and 3 only I have to I can get number. Okay, because every time it will be divisible by number which is 2 or greater than 2. Okay, so factors of any number, like let's say 100. Okay, so factors of 100 are, so first I am going to divide by 2 itself, right? 250, and then 225. Okay, so then after that 2 of 12, so something like this. So I always I have to iterate from 2 because the next number, very next number is always half, or it will be less than half. Okay, so let's say if there is number like 99, so 99 is not divisible by 2, right? So we are going to start from 3 in that case. So 33 is going to be the next factor. So I am going to run my loop. I am going to check for I is equal to 2, I is equal to 3. Okay, I is equal to 3. So let me do one thing. I is equal to 4. Let's check for all the numbers till 6. But we don't need to actually consider this is 4 now, this is 5, and this I is equal to 6. We actually don't need to consider all these numbers. So let's say here I write all the numbers 2, 3, 4, 5 and 6. Okay, so when my I is equal to 2, so what are the numbers? Let's say j is going to be a set of numbers that are divisible by this I is equal to 2. So one number is 4, one number is 4, and one number is 6, and one number is 8. But don't consider 8 because max is 6. So let's consider till our max. So j is the set of numbers which are divisible by 2. Okay, j is the set of numbers that are divisible by 2. Okay, and what are the numbers that are divisible by 3? So 6 only, right? 6 only. And here for 4, what are the numbers after 4? 8. But we don't need to consider that, right? We don't need to consider that. I have told you that is the reason here I have mentioned that I is going to run till max divided by 2. Okay, max divided by 2. So till here only I need to run I. So that is why I don't need to consider this. So when my I is equal to 2, okay, I have to start from I is equal to 2, not I is equal to 1. Okay, so when my I is equal to 2, then j could be 4 or 6, any number. So 4 is also divisible by 2 and 6 is also divisible by 2. So here first union is this between these two numbers, 2 and 4. So this is one union. 2 and 4 is one union. Okay, this is one union because these two numbers are divisible by and there is common factor between these two numbers, right? 2 and 4, there is one common factor. So what are the common factors of this 2? And what are the common factors of 4? 2 only. 2 into 2, I can write it like this. 2 is a common factor. So 2 is in parent group 2, and now 4, I know that 4's parent group 4 is also divisible by this 2. Okay, there is a union between them. There is nothing but there is a union between them. Okay, so if there is a union between them, so let's place this 4 into this my 2 only. Okay, because there is a union between those two numbers and they have a common factor 2. Okay, so I have placed this 4 into 2. So now new parent of 4 is nothing but 2. New parent of this 4 becomes my 2. And after that I check for the union between 2 and 6, because 2 and 6, what are the factors of 2? 2. And what are the factors of 3? 6. 2 into 3. There is one common number between them, that is nothing but 2. So there is a union among them. So let's place them in one parent only, right? So I have moved this 6 to 2. Okay, so I have moved this 6 to 2. So now the parent of 4 is 2, parent of 6 is 2, parent of 2 is already 2. Now in the next case I check for I is equal to 3. So there is one union, one possible scenario only, 3, 6. 3, 6. This is the only one group that I found, right? So 3, 6. So here understand more clearly, 3 and 6. So what are the factors of 3? 3. And what are the factors of 6? 3 into 2. Right? These are the factors. I have already found that 3 and 6 is one union. From this I is equal to 2, j is equal to 6. This is possible that I have already make it clear that 3 and 6 is a union. You know 3 and 6 is a union because 6 can be divisible by 3, right? So 6 and 3 are the union. Now I check for the parent of 6. 6 is saying that its parent is 2 and 3's parent is 3, right? 3's parent is 3 and 6's parent is 6. But 3 and 6 form one union. 3 and 6 form one union, right? Here, but I'm saying, see, 3 and 6 are the two numbers and 6's parent is 2, 6's parent is 2 and 3's parent is 3, right? But now I am saying that 3 and 6 form one union. 3 and 6 form one union. So let's do one thing. I am going to write my code like this. I am going to place this 3 into itself, into 2 parent itself. Why? Because 3 and 6 are forming one union. If 3 and 6 are forming one union, then I am going to check for this parent of 6, and I am going to place this value in for my parent of 3, because 3 and 6 are making one union. Okay, so this is done. After that I is equal to 4, 5, I don't need to check. So here in the updated values, parent of 2 is nothing but 2, parent of 3 is nothing but 2, parent of 6 is nothing but 2, right, and parent of 4 is nothing but 2, all the parents. Okay, now after that I'm going to iterate over each element in nums array and going to find the whether they are all a part of one common parent. So yes, 2 is part of parent 2, 4 is part of parent 2, 3 is part of parent 2, 6 is part of parent 2. Okay, so all these are part of parent 2. So now I'm going to write this same thing in the code and you will get more clear picture of this. Okay, so now let's write the code. So now I am going to write the code for this problem. So first let's create one parent array and create one count array, and the max that I'm going to find in my nums array. Okay, so let's create this, and now after that in our main code, so first we have to find the maximum number. So for that I'm going to use my for each loop for int x to nums. I'm going over each element in my nums one by one, and my max number is going to be nothing but math.max particular number x or any previous max, whatever the value that is there. So in this way I am going to get the max. Now let's count the frequency, the length of my nums array. So for that n is equal to nums.length. This is done. Now after that we have to initialize the parent and count array. Okay, so parent is going to be new int size is going to be max plus 1, because we have to consider all the elements in my parent, right? And count is also going to be same, new int max plus 1. So we have to consider all the elements. Okay, so here I'm going till 6, right? I'm going till 6, max is 6, so I'm going to till 6. Okay, so count is similar, and then we have to check if there is only one number in the array, then traversal is possible. If there is just one number in my array, then traversal is definitely possible. So if n is equal to 1, then in that case let me return true directly. So this is done. And next also if in my nums array, let's say numbers are like this, 1 2 3 4, something like this. Let's say numbers are like this. Okay, in that case I have to return false. Why? Because this, if 1 is present, then GCD of 1 and 2 is not going to be greater than always greater than 1, because this number is 1 itself, and we can only traverse if the GCD of any two numbers is greater than 1. But if a number itself is 1, then in that case we have to return false. So let's iterate over each element in my array one by one. Okay, for int I is equal to 0, I less than n, I plus plus 1 plus plus. If nums of I is equal to 1, then in that case just simply return false. Okay, return false. So this is done, right? So now let's initialize the parent array. So I have told you that I'm going to, since all the numbers are divisible by themselves, so I have parent of 6 is 6 only, parent of 5 is 5 only, parent of 4 is 4 only. So I am placing all the numbers in their own shell, right? So again, for int I is equal to 0, so it is starting from, I'm starting it from 1. Sorry, here I am starting it from 1, right? So for int I is equal to 1 and I is less than equal to max I plus plus, and parent of I is equal to I. So this is what I am doing, right? And also one more thing, we have to count the occurrences of each number. Okay, so to count the occurrences of each number, let's again write one for each loop, int x, iterate over all the elements, and then count of x plus plus. Okay, so in this way I'm going to get the count for each number. Okay, now this is done. So we have counted the occurrences of each number. Then we have to also create one array to keep track of visited numbers during factorization. Okay, if we have already visited any number during factorization, then we don't need to visit it again, right? Because we have already find the minimum or whatever the parents, okay, for that purpose, for that. So let's create one boolean array, boolean visited is equal to new boolean max plus 1. Okay, this is done. So I have created one boolean array, and now we have to factorize the number and perform union find. Okay, we have to factorize the number and perform union find. Okay, so for this I am going to start from 2 only, because we need to consider the factors after 2 only. So I am starting from 2, int I is equal to 2, and I have told you I have to run this loop till max divided by 2, right? So here I can also write it like this: I into 2 less than equal to my max I plus plus, and inside that, if I have already visited the factors of any number, okay, if I have already visited the factors of my I, okay, if I have already visited the factors of I, then in that case I have to just continue. I don't need to again calculate the factors. But now after that, this is a number 2. Now I'm in the J loop, I am going to get the factors of this particular number I is equal to 2. So for that, int j is going to start from I into 2, remember, and it is going until my max j plus plus. Okay, so here inside this, if I am going to mark visited of this particular j, okay, this particular j, the factor is true, I am marking this as true. Okay, I am marking this as true, and now we have to find the union. So if count of any number in my nums array, okay, if the count is not equal to 0, then in that case, let's find the union between these two numbers. So union between I, the main number, and its factor. Okay, so there is a union between them, right? Union of I into j. Okay, so this is done. Now we have to check if all the numbers belong to the same set. So in this let's create one int p, and p is going to be find nums of 0. So initially the number is 2, so parent is 2 itself in the starting, and then I am running one loop, I is equal to 1, I less than n I plus plus, and inside that, if I find nums of I, okay, nums of I is not equal to p, then in that case I have to return false, otherwise I have to return true. Okay, so if all the numbers are in same group, then I have to return true, otherwise I have to return false. This is what I'm doing here. Okay, so this is done. Okay, so now we have to write this union find operation, right? So for that, let's write them. Private let's write it for union first. Private void union. In union I am passing two numbers, int I and int j. These two numbers are passing. Let's say int x comma y, int x int y. These two numbers are passing, and here in the x I am going to again apply the find. I am going to find the parent, the new parent or whatever I get. Y is equal to find of y, If they both are not equal, if these two numbers are not equal, then I have to place them in one same group, right? If x is not equal to y, then I have to place them in a single group. Then for that I am going to just write parent of y is equal to x, okay. So this is done. Now let's write find function as well, because we didn't write it yet. Private int find int x, okay, return parent x is equal to x. If this is true, then in that case we have to return x, otherwise the parent x is going to be, otherwise my parent of x is going to find the next, is going to find again but parent of x, okay. So this is done. So now let's run our code and see if there are any errors that we need to solve. Okay, if visited of error cannot find this symbol, visited of j is equal to true, visited of j is equal to true, and variable visited solution cannot find the symbol parent. Where is this parent? Line number 46. Line number 46, parent of y is equal to x. And what is the issue on line number 26? If visited for int j is equal to I into 2, j is less than equal to max, j plus is equal to, should be plus is equal to I, and visited of j is equal to true, okay. Visited of I, what is the issue here? Let's run it. Cannot find the symbol visited. Spelling is correct na? Oh shit, VISI here, VISI, okay. So this is a typing mistake. Anything else? Missing return statement, line number 37. Line number 37, missing the return statement. Okay, if this is not the case, then let me return it here now. Otherwise we are returning true only. Now all the test cases has been accepted. Now let's submit our code. So our solution is accepted and beats 100% of users with Java. So this was our example, right? 2, 4, 3, 6. So let me do one thing here. Case 3, case 2 is like this, case 1 is like this. So 2, 4, 3, 6, right? 2, 4, 3, 6. So now let's run it and see its output. So it's true only, right? So this was the example that we take. So here what I am doing, so here first I created one parent, okay. So now let's understand the code, how it is working. So let me delete this. So initially parent and count max is taken, so I'm going to iterate over all the elements in my, okay. So let's take this example now, some same example, 2, 3, 6, okay. So here parent, count and max, here in the nums array I have to calculate the max number. So max is 6 and n is equal to nums dot length, which is nothing but 3 in this case. Parent is equal to again 1, 2, 3, 4, 5, 6, okay. Count is again 1, 2, 3, 4, 5, 6. If n is equal to 1, if any number is 1 here, then I have to return. If there is only one element, that's it, just 2 only, then in that case I have to return true. If any number is 1 available, let's say, then in that case GCD is not possible. It should be greater than equal to greater than 1 in order to traverse. So here I am returning that. Then initially I am placing all the numbers 1 to my max in the parent, and then I am going to iterate over all the elements to count the frequencies, like 2's frequencies, 1, 3's frequencies, this one 6 frequency. Then I have created one boolean visited array. Then in this I am going to factorize the numbers starting from 2 till my max divided by 2, 6 divided by 2. So until 3 only I need to find I is equal to 2 and I is equal to 3 only I need to run. So if I is already visited, then I don't need to follow any other steps. I need to continue if that's the not case. So here what's the benefit of using this visited I continue? So let's say 4. Okay, let's say number is 4. Okay, what are the factors of 2? 2's factors are 2. 3's factor, I'm ignoring 1. Okay, 3 is 3. 4 is equal to 2 into 2. 5 is nothing but 5. 5 is equal to 5. 6 is nothing but 2 into 3. Okay, so when my I is equal to 2, then what are the unions that I find? Unions are 2, 4 and 2, 6. In the previous example, I am talking with consideration of previous example. Previous example was this 2, 4, 3, 6. These are the elements. Okay, so these are the factors. Now for 3 and 6 are one union. Okay, and I am also marking all the numbers in J as visited here, right? So this returns true, this returns true, this returns true. Now when my I next time becomes 4, so if my visited of 4 I did, so I get the output as true because this I have already visited, right? So what does it mean? It means that this 4 is not a prime number. Okay, I have already get this in one of my previous factorization value. Okay, for 2. So there is already a factor which is existed and that I have already got. Okay, so for that 4 we need to skip it. So this is we are doing only for the prime factors, right? For 6 we have already visited, so we don't need to check for this one as well. But in our case we are just running till max divided by 2, so we don't need to consider that for this particular example. But they are going to some other example in which we have to consider this thing. Okay, so this is what I am doing here in the here in this code. I am finding whether all the numbers are there in one group. Okay, so this is how my find parent is working, find and unions are working. Okay, this is code for that. So I hope that you guys are able to understand today's problem, and if you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.